episode we're travelling to the furthest reaches of the solar system, the Kuiper Belt and the Oort cloud, because we're going to look at comets. Simply put, comets are cosmic snowballs of frozen gases, rock and dust that orbit the sun. And when frozen, they're a few kilometres across, the size of a small town. Now, when a comet's orbit brings it closer to the sun, it heats up and spews out dust and gases into a giant glowing head larger than quite a few planets. The dust and gases form a tail which stretches away from the sun for millions of miles, and there are possibly billions of comets orbiting the sun in the Kuiper Belt and the more distant Oort cloud. The current number of known comets is about 3,500. Now, fortunately for modern astronomers, Chinese astronomers kept extensive records for hundreds of years, including illustrations of the characteristic types of comet tails, times of their appearance and disappearance, and the position amongst the stars where they appeared. These historic comet documents have proved a valuable resource for modern astronomers. Because today we know that comets are leftovers from the dawn of our solar system, around 4.6 billion years ago, and they consist mainly, as we say, of ice coated with dark organic material, dirty snowballs. And they may yield important clues about the formation of our solar system. Comets may even have brought water and organic compounds, the building blocks of life, to the early Earth and other parts of the solar system. So where did they come from? As theorised by astronomer Gerard Kuiper in 1951, there's a disk-like belt of icy bodies existing beyond Neptune, where a population of dark comets orbits the sun, in the realm of Pluto. And these icy objects occasionally get pushed by gravity or accidents into orbits which bring them into the inner solar system, closer to the sun, and they are what we call short-period comets, taking less than 200 years to orbit the sun. In many cases, their appearance is predictable because they have passed before, like Halley's Comet. Less predictable are the long-period comets, which arrive from a region we call the Oort cloud. About 100,000 times the distance between the Earth and Sun, about 150 billion kilometres. And these Oort cloud comets can take as long as 30 million years to complete one round trip. Each comet has a frozen part called the nucleus, often no larger than a few kilometres across, and it contains icy chunks of frozen gases with bits of embedded dust and organic material. A comet warms up as it nears the sun and it develops an atmosphere, or a coma. The sun's heat causes the comet's ices to change to gases, so the coma gets bigger and may extend for hundreds of thousands of kilometres. The pressure of sunlight, high-speed solar particles, what we call the solar wind, blows the coma dust and gas away from the sun, forming a long, bright tail. Comets, incidentally, have two tails, a dust tail and an ion or gas tail. Now, most comets travel a safe distance from the sun. Halley's Comet comes no closer than 89 million kilometres from it. However, some comets are called Sungrazers, and they crash into the sun or get so close the sun's heat vaporises them. Well, in the modern world, because of our desire to understand how the solar system was formed, and knowing that comets contain the building blocks of the solar system, we've started to explore comets on a more regular basis. In 2004, NASA's Stardust mission successfully flew within 250 kilometres of the nucleus of Comet Wild 2, collecting particles and interstellar dust, which it returned to Earth in 2006. An analysis of the samples that came back from Stardust suggests that comets may be more complex than originally thought, because there are minerals that formed near the sun or other stars are found in these samples, suggesting that materials from the inner regions of the solar system travel to the outer regions where the comets formed. This possibly happens at a time when the sun and other stars ignite and explode into being a star, and as they do so, they blast a lot of the dust and gas that's surrounding them into the furthest reaches of their planetary systems. The best data we have yet of a comet is when the European Space Agency sent Rosetta to Comet 67P, Churyumov-Gerasimenko. On the 6th of August 2014, the spacecraft reached the comet and performed a series of manoeuvres, eventually going into orbit at about 30 to 10 kilometres from the comet's surface. And on the 12th of November, its lander module, Philae, performed the first successful landing on a comet, although certain of its bolts failed to fire, so it didn't stick to the comet surface, it bounced. However, it took some amazing pictures, as you can see. Well, I hope you enjoyed that look at comets, and I look forward to seeing you next time. Thank you. Bye for now.